begin. So let me share my whiteboard, and please let me know if you can't see it. I'm gonna share it in a second. I'll let you know. Okay, just let me know if you can see the whiteboard. There's two blocks on the top, one on the left, one on the right, and the one on the left says the mean, lifespan, etc. Good, yes, fantastic. Okay, so let's go back to it. Okay, so now we moved on to the next learning unit. Okay, now this, if you recall in the last collab, I said that what we're going to cover in that collab, which is the normal distribution, is going to get carried over to the learning units going forward. And you really need to have a good understanding of that in order to do these problems. So keeping with that, that is going to be applied here. It's a build up of that extends into this, okay? And I'll explain now as I go through a problem with you. So please, if you're still not comfortable with what I covered in the last collab, watch it again, work through that practice test that I made available as well. Really make sure that you understand that learning unit, especially the normal distribution, okay? Because that gets carried over into the subsequent learning units. All right, so let's focus on this session. And the problem that I wanted to draw your attention to is the problem on the left. Let's make sure I'm recording this. Yeah, okay. All right, back to the whiteboard. So the block on the left, that's one problem, and let's just focus on that one before we move to the next problem on the right. Okay, so I'll read the question out to you. It says the mean lifespan of a brand name tire is 50,000 miles. Okay, assume that the lifespan of tires are normally distributed and the population standard deviation is 800 miles. So just forgive me for, this problem is actually probably an American-based problem because we're dealing with miles, but if it was kilometers, it's the same thing. It doesn't change anything. All right, so maybe just ignore the miles for a second. Right, you could pretend it's kilometers. It's not going to change how we solve this problem. All right, so let me draw something. You some idea what we're talking about, right? So there's this factory. Let's give it this tire a name, something we all kind of can associate with in South Africa. Let's say it's Dunlop. Okay, so this is the factory, and within this factory they make tires. So each, let me do this in color because I like my colors. Let's go with green. All right, this green here, that's a tire within this factory. This is another tire, another Dunlop tire, etc. Okay, they make tires and they got a whole bunch of them within their factory, as you would expect. Okay, you kind of get the idea. We'll do one more. Okay, and then we'll call it. All right. Now, the part in the question that's in bold, it says the mean lifespan of a brand name tire is 50,000 miles, and assume that the lifespan of the tires are normally distributed, and the population standard deviation is 800 miles. Now, if you recall what we did in the last session, we spoke about the normal distribution, right? Now, I told you, try and envision a histogram, right? And it's symmetric. So if I had to draw this histogram, remember there's all these rectangles, etc. to make up the histogram. And almost done. It's a symmetric histogram. And this line here is what I want to draw your attention to now. Here, it's a bell-shaped curve. So when someone says it's normally distributed, that means it's a bell-shaped curve. So now if you just ignore the blocks, right, I'll draw just the curve now on its own here on the right. Drawing the exact same thing on the right, but I just now don't want to show the blocks. So that part in bold in that question is telling you that the distribution of the lifespan of these tires, so each tire can last about 50,000 miles. So on average, it can last 50,000 miles. And because it's normally distributed, that means that the average is the center here. 50,000 here. So 1, 2, 3, right? So this is your miles. This is the lifespan of the tire. So on average, it lasts 50,000, and it has a standard deviation of 800. Okay, so so I am, let's say, a statistician or maybe just some quality inspector that goes into this factory. All right. Now, before I even look at a tire, I speak to the supervisor or the manager of the factory, and he tells me that uh, he tells me this part in bold, right? He tells me that the mean lifespan of their Dunlop tires is 50,000 miles, and then you assume that it's normally distributed, which means he's telling me assume that it's a bell-shaped curve like this, centered at 50,000 miles, and that the standard deviation is 800 miles. Okay, that's what the manager told me, right, or the supervisor. So now if I just grab a tire, okay, if I pick any one of them, one of these tires, let's say I choose this one. I grab this tire and then I want to basically determine what is, and this is going to question A now, what is the probability of this tire? What's the chance of this tire of its lifespan being less than 48,500? So I grab this tire and I want to know what's the chance that the lifespan of this one tire here, that its lifespan is actually less than 48,500. Right, so here what I drew in this curve here, right, that's the distribution. That's the distribution of the lifespan of the tires. So I'm going to give a variable name to the lifespan. So what you see on this horizontal axis, I'm going to call it X, and that's the lifespan. So what I want to determine for this one tire is what is the probability that X is less than 48,500, with X being the mean lifespan of the tire. I'm going to pause there for a second. Does everyone follow where I am? Does this make sense to you so far? Is there anything that's uncertain? Good. Oh, good. Fantastic. All right. Okay. Now, with that being said, this is something we've already done in the last collab. Remember, X is normally distributed. All right. So that means we can use the tables in the back of our textbook, which we did in the last collab. The only thing I need to do is to convert this X. I need to convert this X to a Z. And to do that conversion, I use this formula here, which is given to me. Z equals X minus mu all over sigma. Right? That's what we did in the last session. If I want to work that out, I need to convert this X to a Z. And how I do that is this is what I'm doing now is just from the last collab. The probability of Z now instead of X less than, and I'm going to follow this formula here to convert this value here to a Z value I can get from the table. So I substitute the 48,500 into this X value here, 48,500 minus mu, and mu is, there's a mu. The mu is what the manager told me that the average is for the lifespan, which is 50,000. Okay, so that's your mu. Okay, and then your sigma is your standard deviation, which is given to you in the question, 800. So that's your sigma, right? All over 800. So there we go. And then you can put these into your calculator. It becomes probability of Z less than, and then if you work out everything here on the right, you should get a value of, and I round it to 2 decimal places, 1.88 minus 1.88. And then I'm going to go and find this probability using the table in the back of my book. So I'm not going to go over how to find this probability. I have to make the assumption that, that you understand what we did in the last collab, and that's pretty much what I'm just doing. So I'm just going to write the answer here. I'll come back to it if you're uncertain how to work the probability, and this means me going back to what I covered in the last collab, which I'd rather do at the end of this session because I need to cover what's this learning unit. Let me just check the chat. Kai, do you mean what page? Yeah, thanks, Arjun. Thank you. 506. Yeah, that's the table, right? Yeah, perfect. Thank you so much. I actually don't have the textbook with me, but thank you for that. All right. So I'm just going to make some space here. And if you work this out, you'll get a value of 3.01%. So that's the answer to the question. If you work it out, if you go to the back of your book and get this probability, you'll get a value of 3.01%. So that's the probability. That's the answer for question A. All right. All right. Now, question B, this is something new. Now, this is content for this learning unit. So the reason I did A is to kind of give you a recap of what we did on the last collab, but also to explain the difference between that content and what we're going to do now. Now, let me just make some space on the whiteboard to explain the next part. All right. So the first scenario for question A is, I, as an inspector, I went into the factory and I just grabbed one tire. Okay. And I want to know what is the chance that this one tire has a lifespan of less than 48,500. The next scenario, and this is question B now. Okay, now I'm looking at question B. The next scenario is, okay, instead of grabbing one tire, I grab 100 of them. So I'm not going to draw 100 green dots, but you get the idea. Let's say I take 100 of them. So not every single tire in the factory. Maybe there's 10,000 tires in the factory. I'm only going to grab a basket and maybe, I don't know what to use, maybe not even a trolley because 100 tires are not going to fit in that. But you get the idea. I get 100 tires, I draw them. Okay. I collect 100 tires, a random sample. And now I'm not looking at one tire, I'm looking at 100 tires, but I'm interested in if I want to know the average of the sample. So that's question 1. In the table, should we look at the value? Yes, Arjan. So remember, in the table, you don't have the minus values. You only have positive Z values. You have to use the property of symmetry to get the value. Okay, Adrian, let me come back to you. I'm going to come back to the right, so let me draw it. Yeah, sure. All right. So what I'm assuming this is what you've done, right? There's positive 1.8. So the value that 46, almost 47% that you found, that's the area here. So when you went to the table and you looked at Z being 1.88, this is your Z axis. The area that you're seeing is this is the 47%. But remember, now look at this part here, what the question's saying. This part here that I'm drawing your attention to. This is Z less than minus 1.88. So minus 1, so there's 0, which is the center. Minus 1.88 is on the left. Right? Minus 1.8. Now I'm going to shade the area that we need to find to answer this question in green. Right? Now it's saying Z less than minus 1.88. So it means this area. Yes. Okay, you got it. Yes. 0.5 minus that gives you that. Okay. Okay, I'm glad that answered that. Okay. So yeah, look, everyone, I'll come back to how, if you want, at the end of the session, of how to go from this step to get that probability. Okay, that's what I did in the last learning unit. And I don't want to focus the bulk of the session on that, okay, because it means I'm just revising the last learning unit. I'll do that at the end after I've covered this content. Right, so let me just come back to where I was. All right, so now remember, instead of looking at one tire, I take a sample of 100 of them, right? If you look at the question, it says 100, right? So I took a sample of 100. Now, this sample, okay, instead of looking at one tire, I want to make some estimate of the average of these 100 tires. So remember, if you just look at one tire, it's X. But if I want the average of a sample, right? So think about it. If I just took 20 students and I looked at their stats mark, right? And if I work out the average, I would add it all up and divide by, oh, did I say 20 students? Okay. Yeah, I would add it up and I'd divide by 20, and that'll give me the average. And you denote the average of the sample by X bar. So it's the same with the tires. If I got these 100 tires and I wanted to measure the average lifespan of these tires, of the 100 of them, I would use X bar. All right. So that's the symbol for the average of the sample. Okay, so that's the difference between X, what I have here, and X bar. X is just a single sample unit. It's just this one tire. X bar is taking a sample and taking the average of that sample. That's X bar. Now in question B, that's what they're asking me. They're telling me that I took a sample of 100 tires, but they want to know what is the probability that their mean lifespan, the mean, this board here, average. Mean is the same thing as average. So this is what they're talking about. They want to know what is the probability that this average, if you read this part here, what is the probability that their average is more than 50,200? That's what they're asking me. I'm going to pause there before I move on. Does everyone understand why this question is formulated like what I've written here? Perfect, perfect. Thank you. All good? All right. Okay, fantastic. All right. And now the way I'm going to answer this is a bit different to how I've done it here. Okay. Before it was X, it was just one sampling unit. Now I'm talking about the average in the sample. So I still need to convert it to Z, like how I went from this step to this step. I still need to do that. But the only difference now is before I use this formula to go from X to Z. X minus mu all over sigma, right? That's the formula I would use before when I'm just talking about one tire, right? But when you're talking about an average, the formula you need is this, and you don't need to memorize it. It's in your formula sheet. It's Z equals, okay, which we need with X bar here, X minus mu, but the bottom, the denominator is slightly different. The bottom is sigma divided by square root of n. That's the formula. So we need to use this formula to go from X bar to Z. Okay, you don't need to understand why this formula exists. It's beyond the scope of this course. It's yeah, it would take easily a couple sessions to cover it, but we don't cover this in this course. You're not going to be examining it. So you don't need to know why this formula works. You only need to know that you apply it when you have X bar. All right. You just need to know when to apply it. So now, when I want to go from X bar to Z, I'm going to use this formula here. All right. So what happens is, I'm going to go back to my pen. Let me just make some space on the board. Okay. So now I'm going to use this formula here, right, to go to the next step, which is converting it to Z. So now it becomes, remember, we're not talking about X bar anymore. We're going to talk about Z. And we're going to use, we're going to use this formula here to convert this value to a Z value. So now we replace the X bar with this value. Okay, so it's 50,200 minus mu. Okay, minus mu, we're following this formula. Remember, mu is still the same as it was in the question, nothing changes, it's 50,000. And then in the denominator, it's sigma, which is still the same as before, 800. Okay, so it's 800 divided by square root. And what is your n here? Remember, I told you, n is the sample size. So how many tires did I have in my basket, my sample? Yes, exactly. So that's exactly it. The n is 100. So I substitute the 100 here. Okay, perfect. Now I just plug that into my calculator. It becomes probability of Z greater than. And if you work that out, you put in your calculator, I think you'll get a value of 2.5. Yeah, fantastic. 2.5. Thank you, Kai. I'm on the right track. Okay, and now we're back to what we did in the last Colab. You use your table, you can sketch the curve, shade the area that you're interested in. The answer to that is 0.62%. 0.62%. All right, and that's your answer for question B. Okay, so remember this step here, how I get the final answer, this is covered in the last Colab. So I will go over it if you need me to, but in the end of the session. Okay, but if you understand everything going from here to here, and then to here, just to this part, then great. Well, that's okay for me for now, and let me know otherwise though. So are we all good? Do you get those steps? Fantastic. All right. Okay. And now I'm going to move over to the next question on the right block. Okay. Now, let me make some space. Okay. Just a note, you sometimes can get asked, what is the standard error? Okay, and they may ask you to work that out. All you need to know, the standard error, if you look at all your Z formulas, right? We're going to do another Z formula now in a second. But for this Z formula, if you look at what's in the denominator, right? Whatever is in the denominator for your Z formula, that's your standard error. So if you had to work out your standard error, it would just be what's in the denominator, which is sigma over square root n. Okay, just know that. That is your standard error. The standard error is whatever's in the denominator of that Z formula. All right. Okay, let's move on to the next question on the right. And this is the last question I'll cover for this evening. Let me check question. Good. Fantastic. All right. Now, the second question says, in a certain neighborhood, it is known that 12% of school leavers are unemployed. All right. If a random sample of 150 school leavers are selected, what is the probability that the sample contains less than 15% unemployed people? Now, in a very similar way to this example I did before. Okay, now maybe I'm a researcher and I go to this neighborhood and the mayor tells me, okay, I have to take the mayor's word on this. The mayor tells me it's known that 12% of school leavers are unemployed. All right. So what I need to do is I need to go and sense check this. I'll take a random sample of 150 school leavers. All right. So there's a sample. I take a sample of 150 school leavers, and then the question I need to answer, which is here. What is the probability that the sample contains less than 15% unemployed? So remember, there's my sample. I'm going to try to fix this up there. I have 150 people in this sample. Okay, I haven't asked them the question individually as yet. I might go to this person here and ask them, hey, are you unemployed or employed? And then tick that one, yes or no. Then I'll go to this person and ask them the same question, etc. I got to ask all of them, all 150 of them, whether they are unemployed. Okay. Now there's 150 people here. So what I'm being asked here is, out of those 150 people, what's the chance that the proportion of them that are unemployed is less than 15%? Now remember, I think it's in your learning unit 1, you would have come across the symbols for statistics and for the population, right? So for the big population, so let's just say this is just a neighborhood, right? This is just a neighborhood. Sorry, let me take it back. This is my sample. This is 150 people within my sample. But in the grand scheme of things, there's the neighborhood, the whole neighborhood. There's just too many people for me to go and look at an entire neighborhood, right? But the mayor tells me it's believed that out of the entire neighborhood, the proportion of unemployed people is 12%. It's 12%. So pi is 12%. That is what the true value is. And that's what I'm being told by the mayor. But my sample, this I can measure. I can look at 150 people, 50 people, because that's doable. So the proportion for the sample, although I'm measuring the exact same thing as what pi is, just because it's on a smaller subset or it's on a sample, then the symbol for that is different. The symbol for the proportion here is p. That's the proportion for the sample. So what I'm being asked is, looking at the sample, looking at this question here, what's the probability that the sample contains less than 15% unemployed people? So they're asking me, what is the probability? I'm going to write capital P, that small p, the proportion of the sample, is less than 15%. That's what I'm being asked. I'm going to pause there. Does that make sense, everyone? Is it clear what I'm formulating here? Fantastic. Very good. All right. Now that I've formulated this problem, I need to just use my table in the back of my book again. So that means I need to go and convert this to a Z value. And the formula you're going to use for that, which you don't need to memorize, it's given to you, is this formula here. It's Z equals P minus pi all over square root pi into 1 minus pi all over n. Just note that everything in the denominator is falling under the square root sign. So I know it's a lot of stuff in this formula. You don't need to memorize it. It's given to you. You just need to know when to apply it. Okay. So that's the formula you need to use. So for me personally, what I do is I work out this denominator separately. All right. Now I'll tell you why in a second. So what I'm going to do is I'm going to move this formula here that I'm talking about, P to Z, by using this formula here. So this is going to become probability. I'm no more talking about P, I'm talking about Z. Now to convert this 15% to a Z equivalent value, I use this formula here. Right? So for the P value, it's going to be 15%. So it's 15% minus pi all over this entire denominator here. Right? So it becomes square root pi into 1 minus pi. Oh, sorry. Pi into 1 minus pi all over n. And we have all the values we need to substitute in this formula. Pi, it's what the mayor claimed the unemployment rate is. Here's what the mayor claimed the unemployment rate is. And your N, well, that's your sample size. And if you look at the question, there it is. It's 150 people. So your pi is 12% and your N is 150. So if you substitute these values into the equation, all right, if you do that, then this whole thing, let me just circle it in red. This whole thing here will become, maybe do you want to give that a shot in your calculator just to see if you're comfortable working this out in your calculator, because you're going to have to do this in your exam. I have the value already, but I'd rather you just work it out and let's see if we all get the same value. Give it a shot. Yeah, 1.13. That's right. Very good. Very, very good. Okay. Glad to see you're comfortable with that. So that becomes probability Z less than 1.13. 1.13. And then we go to our table in the back of our book and we find this probability. And if you do that, you'll get a value of 87.1%. 87.1%. And that's your final answer. Done. That's it. All right, so just one more note I wanted to make. Remember what I told you what your standard error is? Your standard error is whatever's in the bottom of your Z formula. So for this problem, okay, when you're talking about proportions, your standard error is what's in the bottom of the denominator, which is this entire thing here under the square root sign. If you had to work with your standard error, it's just what the denominator is. All right, that's what I wanted to cover. And yeah, that's it from my side. So do you want me to go over how to get the probability, or anything specific you want me to go over? Is everyone comfortable getting these probabilities in the last step? Or do you want me to go over that? All right. So again, you mean on this last one, right? How I get the 87.1%. All right, cool. All right, so I'm just gonna share the board. Space for them. Cool. All right. So first things first, let's sketch the curve. All right. And sorry for using red. I'm gonna draw the bell-shaped curve here. Okay, so remember on the horizontal axis is our Z value, which is centered at 0. And then I want to know what is the probability that Z is less than 1.13. So remember it's centered at 0. So 1.13 is a positive value. So it will be on the right of 0. And it's somewhere around here. It doesn't have to be accurate. You just need to know, is it on the right or on the left of 0? And it would be on the right. So there's it here. So on this point here, where it cuts the Z axis, that's your 1.13 mark. Right, there's your 1.13. Now, because we find the probability that Z is less than that, just like we did in the last collab, to work out the probability, it's the same thing as working out the area under the curve. So Z less than 1.13 means everything from here and less than it, going that way. So I need to work out the area under the curve here as well. I'm going to use one more color, as well as this area here. It's all the area in this direction here, all right? So it's this green area as well as the blue area. And that will give you your probability. Does everyone understand that? Good. All right. Okay. All right. Now, let's just look at this green area, because you won't really need your table to work this out. Remember what we said about the area of the curve, right? The total area under the curve is 1. And at the 0 point, it splits the area exactly in half. So what is the size of the green area? Very good. It's 50%, right? So the green area is 50%, 50% or 0.5. Okay, however you want to write it, 0.5. And the only thing left to work out now is the blue area. Now, for the blue area, that's where we use the table in the back of our book. That's where we need to use the table. Now, I'm going to open my textbook. You just give me a second. I'm just going to stop sharing my screen for a second so I can open my textbook. Please bear with me. So I've got an older edition, but the table is still the same. So now you're on page 5 or 6. Mine is getting there. Ha, okay, up there. Okay, I'm going to share my screen again. Okay, just let me know if you can see the table in my textbook. Everyone can see that? Sorry, just checking, going back to the chat. Yes, yes, yes. All right, fantastic. Go back there. So remember, let's go back to the whiteboard. We know the green area. It's just a matter of figuring out what the blue area is now. So remember, the value on the z-axis is 1.13. Go to our table and look at the corresponding 1.13 z value. Because to find that value on the axis, it's figuring it out by looking at what's going down the column on the left. So there's 1.1. There's it here. 1. Trying to highlight this part here. 1.1. Everyone can see that, right? There's your 1.1, and the second decimal is 3. 1.13. So it is there. It's where these two intersect. So there and there, it's 0.3708. Does everyone see that? So that's the blue area. So the blue area is 0.37. Let's just round it to one more. Does everyone get that? Looking at the table, everyone understand why it's 0.37? Yes. Yes, yes, exactly, Jan. Yeah. So remember now, the answer to the question was to work out the entire area on the left of 1.13. So that means adding the blue area up to the green area, and that's the total area. So it's this and this added up. If you add them up, that will give you the total area, which is 0.871. You can leave it as a decimal, but I just wrote it as a percent here. It's the same thing. Does that make sense, everyone? Does everyone understand? Good. Happy? Okay, fantastic. All right. Okay, that's what I wanted to cover this evening. That's pretty much it from my side. Any other questions? Anything you want to know, discuss? Standard error. Felicia, the standard error, all right. You got two Z formulas. It's, well, you actually have three. It's Z equals X minus mu all over sigma. Chat, hold on. Give an example of how they would ask the question. How they would ask it. Okay, let's look at this problem here, right on the right, in a certain neighborhood, etc., etc. After giving you all of this text here, they would simply just say calculate the standard error. That says it. That's as simple as it. The question would say calculate the standard error. Right. So for this question, remember the formula we're using is for proportion. So it'll be Z equals P minus pi all over square root pi into 1 minus pi all over n. All right. Let me see the chat. Okay, no worries. All right. So remember what I told you the takeaways for the standard error. The standard error is whatever's in the bottom of the fraction for all of your Z formulas. So for this problem, we would be looking at this formula because we're talking about proportions. It wouldn't be the other one, which we did earlier. It would not be this one. Z equals X bar minus mu all over sigma over square root n. Why? Because these are averages. And this problem that we're looking at on the right has nothing to do with averages. So this equation does not hold because it's with averages. You have mu there. This one doesn't apply because it's also averages. It's this one that applies because we're talking about proportions. So the standard error is everything that's in the denominator. So if they ask you what is the standard error, you would just work out what is in the denominator. And I'm going to circle that in red. It's this thing here. So to work out the standard error, okay, you just need to work out what the denominator is. And that would be, so your standard error, let me just use my pen, make some space. And blue, black. Okay, so standard error is equal to whatever's in the denominator, which is square root pi into 1 minus pi all over n. And everything is under the square root sign. So just to check that you can work this out, here's your pi value. Your pi is 12%. It's in the question. Pi is equal to 12%. And your n is 150. I have the answer already, so maybe just give it a shot. Plug the values into this formula. See what you get. Yes, 0.027. Very good. Kalisha, you want to give it a shot? Did you get the same answer in your calculator? 0.027. And that's your standard error. Very good. No problem. Okay, so remember, if you were talking about the problem on the right, then this would be your standard error. Okay, but if you were talking about the problem on the left, so let me just clear the board again. Let's be quick. Okay, so if we are talking about the problem on the left, which is this problem, this was the question, then here your Z formula is this, Z equals, and especially if you're talking about B, right? If you're talking about the sample mean, so it'll be X bar minus mu all over sigma over square root n. sigma over square root n. So here what's in the denominator is this. It's this. So that's your standard error. So for this problem, your standard error is just that value, sigma over square root n. So your standard error here is sigma over square root n. And your sigma here is 800 in the question, and your n is 100. Plug that in, and you should get, yes, 80. Remember, your sigma is 800. So right, so your sigma is 800, and square root n is 10. So square root of 100 is 10, but you can plug all of this one time in your calculator. Do that and you get 80. That's your standard error. Yeah, no worries. But as long as you understand that. Does it make sense, everyone? Perfect. Glad to hear it. Cool. All right. All good? Any more questions? No problem. No problem at all. All right, everyone. That's it for this evening. We'll chat soon. Okay, and yeah, finish your ice off. Okay, please complete them. Have a good evening, and we shall chat soon.